Now we're on question 2, paper 2, January 2018. And first 4 questions, definition questions. So these are things you either knew it or you don't know it. Or you could just, use whatever information you would have learned throughout school to answer these. It doesn't have to be exactly like what's in the book. Okay, so it says here phosphoric acid, H3PO4, they were nice enough to give us this, is a common additive in most soft drinks. It can react with sodium hydroxide and alkali to form both normal and acid salts. So they went on to ask us to define acids, alkalis, acid salts, and normal salts. An acid is a substance containing hydrogen which can be replaced directly or indirectly by a metal to form a salt. An acid is also a proton donor. And so we have here an alkali. An alkali is a base which dissolves in water to form a solution that contains OH ions. Define the terms acid salts and normal salts. In acid salts are formed when hydrogen ions in an acid are only partially replaced by metal or ammonium. And normal salts are formed when all of the hydrogen ions in an acid are replaced by metal or ammonium ions. Now, if you didn't know how to answer these, I would have suggested in your mind, if I was a little person living in your mind, to answer 2, 3, and 2, 4 first, and then you could go from there. You could even answer the rest questions and just go from there. And you could have come up with a plausible definition for acid, an alkali, acid salt, and a normal salt. So it says now, state the molecular formula for the normal salt formed from the reaction between phosphoric acid and sodium hydroxide. Hey, if you don't know how to do this first, go down to the balance equation, because I said here, write a balance equation to show the formation of the normal salt in A3. So that's what I would advise you to do. So here goes. So we'll write H3PO4 aqueous plus 3NaOH aqueous. And I usually do these questions before I come online. That's why you would see the equation is already balanced. Plus 3 moles of water. Okay, so again, they gave us the acid up here. At least that helped us a lot. And then once we have the acid, we also know what sodium hydroxide is. We know what it is. And then from this, you can get a metal salt or salt. So you get a phosphate. So it'll be sodium plus the phosphate. And the phosphate ion carries a 3 minus charge. So you get a 3 here. And then you get 3 moles of water. Now you have 1, 2, 3, 4, 5, 6 hydrogens. Do we have that? Yes, we have 6 hydrogens. We have the same anion over here, PO4, PO4. We have 3 oxygens, we have 3 oxygens. We have 3 sodiums, we have 3 sodiums on both sides. So we are good to go. So what is the molecular formula of the normal salt formed from the reaction between the phosphoric acid? This is the salt and this is the molecular formula. So you just write it back here. So again, if you didn't know the answer out of your head, if you didn't know it one time, you could have gone write the equation, the stoichiometric equation down here, and then once you came to the conclusion that this was your salt, you put it right back up here. Now, it says state the molecular formula for an acid salt formed from the reaction between phosphoric acid and sodium hydroxide. Remember, with an acid salt, it will contain all of the hydrogens they wouldn't have ionized completely from the acid. So the acid salt will contain some of the hydrogen ions from the acid. So the salt it wouldn't just be the metal and the anion, the cation and the anion, in terms of just like how you would see it here. It wouldn't just be this reacting with this, because this wouldn't ionize fully. This doesn't ionize fully, so only like one hydrogen gonna come off, or two. You have, this is a tri-basic acid. It has 3 hydrogens, so it has 3 protons to play with, 3 protons to lose. So because of that, you could have it sometimes not fully ionizing in solution. So an example is we have the 3 ions here. So if you fully ionize, you would have the phosphate ion coming off. If it partially ionizes and loses 2 hydrogens from the original H3PO4, then you will have this ion forming with a 2 minus. If 1 hydrogen ion is lost, you have H2PO4 with a minus sign. So you need to learn your anions here. So with this now, I could choose anyone. You could choose anyone you want. I would choose this one because it will be easier, because if you have a Na plus and you have the anion here, H2PO4 minus, it's just a negative and a positive that cancel out each other, so you just stick them together and you get NaH2PO4. So your headache is gone. Okay, then now it says write a balanced equation to show the formation of the acid salt in 4. Okay, so this again, you're going from you want the easiest one to do. You don't want a headache, so you pick ones that are have oxidation states of plus or minus, and you add here NaOH. So the beginning is just like the original equation. Remember the original equation? The beginning is just like that, see? And then the acid is gonna be, the acid salt would have a hydrogen in it. This doesn't have a hydrogen in it, so you're gonna have here Na, and the same thing you had up here, H2PO4 aqueous, and then you get your water. Okay, and if you look at it closely, your balance, if you look, how many H's do you have? You have 1, 2, 3, 4. You have 1, 2, 3, 4. Good. How many phosphate ions? This went over the same, so don't worry about that, but we're going to count this oxygen here and this oxygen here. How many sodiums? You have this and this right here. So your balance. Then it says a solution of 0.05 mole of phosphoric acid has a pH of 4, and a solution of the same concentration but a different acid, such as sulfuric acid, has a pH of 1. Which of the 2 acids is stronger? Of course, the one with the pH of 1, because the lower the pH number, the more acidic the substance. So it's the sulfuric acid. Okay, then it says Jeffrey complains of pains due to excess stomach acid after consuming too much orange juice. Name 2 acids present in orange juice. That's easy, right? We already know that orange juice contains citric acid and the other one that most fruits contain, ascorbic acid. So we know those 2. Then it says state the type of chemical reaction that takes place in the treatment of excess stomach acid, and it's the neutralization reaction. And now it says, hence, name one substance that can be used to treat stomach acid. You could get, it's always a base. Once you talk about acid, neutralization, you get a base. So you could use magnesium hydroxide, which will be present in the medicine called milk of magnesia. You could also use anything hydroxide, bicarbonate of soda, those kinds of things you can use. And also refer to your concise texts. They're all there. Okay? So that's it for this question. Total 15 marks. So please make sure you learn your acids and bases and stuff like that. So just to recap, last year I remember they made the children write down a lot of definitions. So make sure you know all the definitions. Go to the book, write down your definitions, be acquainted with them, because if you get questions like these are easy marks, easy single marks that you could get. And if you don't get them, suppose you didn't know these, suppose you were not confident in your exam, then you would lose 4 marks. So remember all the definitions. The Na3PO4, this is Na3PO4 simply because this is Na plus, PO4 3 minus. Remember that this comes here and this goes there, and so we have Na3PO4, ignoring the pluses and the minuses, the signs. Then you have to learn how to balance your equations. If you're not strong in that, please go back to your books and learn how to do that. Just remember, if you have an acid and a base, you will get a salt plus water. And this was in the question before that with the titration, question 1. Acid salts contain hydrogen because the acid did not totally ionize in solution, so it will contain this hydrogen in here. Then you need to learn your anions. And once you learn your anions, you know how to do the equation properly, like this one. pHs, the higher the pH, the more alkaline the substance. Acids range from 1 to 6. So anything 1 is being the highest and 6 being the lowest for an acid, and then 7 is neutral. Anything after 7 is alkaline. Citric acid, ascorbic acid, neutralization reaction, magnesium hydroxide. All right, I really hope this helped. Have to get to work. Enjoy your day. I will enjoy my day. See you later for question 3.